So in terms of file import, the last function we're going to cover is actually not something that is usually in a standard MATLAB installation. That's MDF import. You can go onto the MATLAB file exchange and find this code simply by searching for MDF import. It comes in a zip folder, which may be trouble getting behind a firewall. But the issue, or the zip file contains the MDF import script as well as the license files, help files, and that kind of stuff to make it work. So there may be tools existing inside people's companies who are watching this that do effectively the same thing. If not, or if you haven't run across one of those, then you definitely want to check this out if you're working with Inca files from ETOS products. I'm sure there's also very similar tools that are available for other calibration interfaces for doing vehicle and engine calibration, transmission calibration. So I'm going to first show you the graphical user interface mode. So it's a similar functionality to what we had in the UI import script that we worked with in the previous module. So you type in MDF import after you extract the stuff. So the MDF import either has to be in your in one of your search paths for MATLAB M functions, or else it has to be actually in the directory you're working in. But it has a complete menu system here. So we're going to go open MDF file. And what I have here in my workspace is basically a throttle opening sweep for some engine data. We go from very closed throttle at 12 kPa, 1000 RPM, all the way up to 99 kPa in fairly small increments. As we go up, there's maybe 20 files here. So I'm going to pick one, anyone. Hey, 74 kPa, why not? So I'm going to hit open. When I do so, it knows how to read the data files structure from Inca. So it actually comes up with the names of all the variables that are contained in here. And it also shows you what the sample rate was. So I'm going to grab a couple of these. Let's grab exhaust precat. That's a temperature or an ego signal. We'll find out. MAF, so manifold airflow. What else can we grab? There's RPM. Somewhere there's a torque too. Let me see if I can find the dyno torque. There we go, 10 milliseconds. I want to get something with different sample rates so you can see how it imports the data. So you can also hit this arrow, which will bring all of them over. And depending on what you want to do, you can hide the device names or add the device names. So this shows you in Inca, gives you a little idea of how it got in there. So it's CCP, those you're familiar with CAN, in Inca will know that's CAN, CAN calibration protocol. Should know my acronyms. It's just a generic algorithm for doing calibration. There's some thermocouples in this system, an ES420, and some other things going on. So that just gives you a little more information, less information that you want. So import signals to workspace or to a MAT file. So you can either bring them directly in the workspace or shoot them to a MAT file. Here's where things can get kind of confusing. We have things at different rates, and we'll talk more later when we talk about how to resample data. But here I've got dyno torque coming in with a sample rate of 10 milliseconds, and exhaust precat coming in at 100 milliseconds, and these coming in with I don't know what, list 1, list 4. We'll see when we import it what the rate is. But what it'll do is either give you a string that has what the sample rate is, or a number underscore for, so all the things that have a matching time vector will come out. There'll be a time underscore 1, a time underscore 2, a time underscore whatever, and each of the variables that are associated with that time vector will have the same underscore after it. You can also use these right here. I typically don't do this. Create ideal uniform time vectors. I've played with that a little bit, and things don't tend to work well for that, from what I found. So it's possible that was an older version, but I usually do it on my own. But it will essentially resample things and give them a common time rate, but I kind of like to know what I'm doing rather than what this software is doing when I do that. But it actually does cite there for some reason. List 1 appears up here with no sample rate. Down here I can apparently see that it's 0.007. So I'm going to import signals. Hopefully I clicked on import signals. There we go. And things show up. So here you can see I've got my 4 variables came in, and I've got my 4 time variables. Not really sure how it gets the numbers, time 3, time 9, time 10, time 13, but you can see the different sizes. So all 4 of those time vectors, although they span the same time, if I go over here and look at maxes and mins, they're all going to start at 0, and they're all going to end at roughly the same time. This was apparently a 30-second data log for each of these variables. So even though it's over the same period, they do have different number of elements. So if you're going to plot any of these versus time, you need to associate them with the correct So if I want to plot the math, so the math sensor, I'm going to have to use time underscore 13 and math underscore 13. And it probably would help if I wrote 13 instead of 12. And that's our math signal in the engine. And obviously if we change this and plot versus the wrong time variable, so time 3, plots must be the same lengths, simply because time 3 is 3000, time 13 is 4289, so things can't be plotted together. So again, that's the manual way of bringing things in using the GUI. A more common way would be to use the GUI to set up what you want to do. So let me close, get rid of the data that's in the workspace right now. It's also going to be more common if you're processing lots of data, which is usually the case, is to go into command generate and hit generate. And it's then going to plot on here the command I would need to call from a script file or from the workspace to do the same job that I just asked it to do. So again, if you have repetitive data files, which in this case I showed you we have about 20 of them, you could use this command right here and simply change the name right here, and you're going to get all your stuff brought in. And here it gives me it says copy and paste command from here to use. So if I run this, which I think it actually just displayed that on the screen, it didn't actually run it. So let me Control C, Control V, hit this. I'm going to get, well, that's interesting. Create it as a cell. That was not what I asked it to do. Let me go back in here and see what we got going on. Of course, a live demo wouldn't work, right? So command generation, generate command. Not sure exactly how I botched that up, but get rid of answer. There I've got the exact same thing that I did before. That's curious. Anyway, I've never had to do that before, so I must have just copied and pasted something incorrectly. So you can see I got the same variables in the workspace I did as if I used the GUI version, and that would allow you to automate things. And I actually have an example of doing just that, which we'll talk about this more in a bit. But this is a really quick way to do it. So I've got all of those files listed here. All the DAT files. And this is a really simple one I call batch load. And we'll talk about this in a second. I just wanted to show you how simple it is to load in lots of data. Let me get rid of, let me comment out the pause. If I can use the right keystroke there, hit the Shift or Control key. So this is basically going to open up. What this does is get all of the files in the directory that have a .dat extension, and then I'm going to cycle through those one by one and call MDF import to bring in all the data. I'm just plotting the dyno torque. I'm going to run this. It's going to spit out a bunch of figures. I think I overwrote all my figures. Let me go back. Yep, I close all. Let's try this one more time. There we go. So it's basically opening each one of those files as I increase in throttle position and plotting out what the torque was. So now I got 17 figures. That must be how many data files I happen to have. So if I want to do operations, some kind of calculation, or you know, average the data and put it into a spreadsheet or whatever I wanted to do, all of that would have been possible, you know, on a per file basis. And we'll talk more about this as we go into more depth in some of the other modules later. So that should give you a basic understanding of this tool. And most of the file opening tools you'll get will have a similar structure where you can either do it from the command line or either do it from a GUI, or else construct it using the GUI and then recreate that as some kind of function or a M-file code that you can actually paste and use on your own to be a little more flexible in terms of automating things.